Hello everyone, this is project presentation video on the topic Bandwidth Management System. We are group KU-Link 5.0 GHz and the team members are Abiral Adhikari, Sadikshya Pokharel, Soniya Sharma, Samir Wagle and Reewaj Khanal. So let's start with bandwidth. Bandwidth is the maximum amount of data that can be transmitted over a computer network in a given period of time. It is usually measured in bits per second, but if the data is huge, we measure it in megabits per second or gigabits per second. Bandwidth management. It is the process of controlling and monitoring the flow of data in a computer network. Bandwidth management system comprises of software and hardware systems that are used in bandwidth management. But why do we need bandwidth management system? Bandwidth management system helps in optimizing the network performance and helps in preventing network congestion. Objectives of our project: to set up a virtualized network environment using VirtualBox and virtual machines that use Ubuntu as the operating system, to configure OpenWRT firmware on the virtual machine network interfaces to enable bandwidth control, to limit the upload and download speed of virtual machine network interfaces to specific values using OpenWRT firmware, to evaluate the effectiveness of the OpenWRT firmware in controlling network bandwidth by measuring the network performance in speed.Net website, to provide a step-by-step guide for implementing bandwidth control in VirtualBox.
It's me, Soniya Sharma, one of the project member of KU-Link 5.0 Bandwidth Management System. Today I am going to talk about the bandwidth management technique. At first, we have the bandwidth allocation or rate limiting, the process of assigning a specific amount of bandwidth to different users or applications in order to ensure that resources are used efficiently and fairly. यसलाई चाहिँ हामीले कसरी बुझ्न सकिन्छ भन्दा कुनै पनि कम्पनीको नेटवर्क इन्भाइरोमेन्टमा चाहिँ डिफ्रेन्ट लेभल अफ युजर्स हुनसक्छ जसलाई चाहिँ डिफ्रेन्ट रिक्वायरमेन्ट हुनसक्छ ब्यान्डविथको। जस्तै फिनान्स डिपार्टमेन्टको युजरलाई चाहिँ धेरै ब्यान्डविथ चाहिन सक्छ भने मार्केट डिपार्टमेन्टको युजरलाई चाहिँ थोरै ब्यान्डविथ चाहिन सक्छ। त्यही अनुसारले नै ब्यान्डविथ एलोकेट गर्नुलाई नै ब्यान्डविथ एलोकेसन भनिन्छ। ट्राफिक पोलिसिङ, यो टेक्निक चाहिँ एउटा process of monitoring network traffic to ensure that users do not exceed their allocated bandwidth or violate other network policies. यसमा चाहिँ के हुन्छ भन्दा ISP इन्टरनेट सर्भिस प्रोभाइडरले चाहिँ एउटा लिमिट सेट गरेको हुन्छ डेटा चाहिँ युजरले डाउनलोड गर्न सक्छ भनेर। यदि त्योभन्दा बढी लिमिट एक्सिड भयो भने चाहिँ दे क्यान स्लो डाउन द प्रोसेस, थ्रोटलिङ द deliberate slowing down of network traffic in order to reduce bandwidth usage and prevent congestion. Quality of service चाहिँ के हो भन्दा एउटा नेटवर्क म्यानेजमेन्ट टेक्निक हो जसमा चाहिँ सर्टेन टाइप अफ ट्राफिकलाई चाहिँ प्रायोरिटाइज गरिन्छ ओभर द सर्टेन टाइप अफ अदर्स ट्राफिक इन अर्डर टु इन्स्योर द्याट क्रिटिकल एप्लिकेसन रिसिभ द नेसेसरी ब्यान्डविथ। अनि त्यसपछि वी हेभ ट्राफिक सेपिङ, जुन चाहिँ एउटा प्रोसेस अफ रेगुलेटिङ द फ्लो अफ डाटा अन अ नेटवर्क हो इन अर्डर टु प्रिभेन्ट कन्जेसन एन्ड इम्प्रुभ पर्फर्मेन्स। कन्जेसन कन्ट्रोल चाहिँ एउटा टेक्निक हो जसमा चाहिँ used to prevent network congestion by regulating the flow of data and ensuring that resources are used efficiently. Congestion चाहिँ कति बेला हुन सक्छ भन्दा जब चाहिँ हामीले सप्लाई गरेको ब्यान्डविथ भन्दा युजेस अफ ब्यान्डविथ धेरै हुन जान्छ, त्यति बेला चाहिँ कन्जेक्सन अकर हुनसक्छ। त्यसलाई नै प्रिभेन्ट गर्नको लागि गरिने टेक्निक नै कन्जेक्सन कन्ट्रोल हो। फेयर युजेस पोलिसी, a policy used by service provider to ensure that all users have fair access to network resources, typically by setting limits on the amount of data that can be transmitted within a certain time period. कुनै पनि सर्टेन पिरियड अफ टाइमको लागि चाहिँ सर्टेन अमाउन्ट अफ डाटा ट्रान्समिट गर्न सक्ने भनेर लिमिट लगाइएको पोलिसी नै फेयर युजेस पोलिसी हो। यो पनि एउटा ब्यान्डविथ म्यानेजमेन्ट टेक्निक हो।
So hello everyone, this is Reewaj Khanal. Now I'm here with the tools and services used in our project. First of all, we have Oracle VirtualBox. Oracle VirtualBox is a powerful and widely used open source visualization software that allows users to create and run virtual machines on their desktop or laptop computers. It enables user to install and run multiple operating systems on a single machine. Simply, Oracle VirtualBox भनेको के हो भन्दाखेरि एउटा इक्जाम्पल दिएर म बुझाउँछु। जस्तै हामीलाई एउटा राउटर चाहिएको छ, त्यो राउटरलाई हामीले त्यसको भर्चुअल टाइप बनाएर चाहिँ हामीले कम्प्युटरमा युज गर्न मिल्छ। सो फर द्याट पर्पज हामीसँग चाहिँ ओराकल VirtualBox भन्ने सफ्टवेयर रहेको छ। त्यसले चाहिँ हामीलाई जुन डिभाइस हामीसँग छैन एभाइलेबल राइट नाउ त्यसको चाहिँ हामीले एउटा भर्चुअल इन्भाइरोमेन्ट क्रिएट गरेर त्यो प्लेटफर्म चाहिँ युज गर्न दिन्छ. Simply Oracle Virtual Box means that. Also, moving to next tool, we have Ubuntu. The Ubuntu operating system is based on Linux. Computers, cell phones, and network servers are all supported in this operating system. Canonical Limited, based on United Kingdom, has created this system. All the principles utilized to create the Ubuntu software are based on open source software development principles. उबुन्टु भनेको कस्तो भन्दाखेरि एउटा अपरेटिङ सिस्टम विच इज बेस्ड अन लिनक्स. अनि हामीले जे पनि डिभाइसेसहरू चलाएको हुन्छौँ, कम्प्युटर, सेलफोन्स एन्ड एभ्री नेटवर्क सर्भर्स, त्यो चाहिँ सबै हाम्रो चाहिँ सपोर्ट गर्छ उबुन्टुले. सो सिम्पली उबुन्टु किन यति पपुलर छ भन्दा ड्यु टु यो सिम्प्लिसिटी. अनि it is also one of the most popular Linux distribution for newcomers. It is an operating system based on Linux Torvalds Linux kernel, a Unix-like system released in 1991. Linux distributions are often free and open source, and many of them are excellent alternatives to mainstream operating systems such as Windows and Mac operating system. Moving to next tool, we have OpenWRT. OpenWRT is an open source project that provides firmware for wireless routers and other embedded devices. It is a Linux based operating system that is highly customizable and can be used to replace the factory firmware on many different brands and models of routers. Simply OpenWRT भनेको कस्तो भन्दाखेरि हामीले चाहिँ यो एम्बेडेड डिभाइसेसहरुमा युज गर्ने एउटा अपरेटिङ सफ्टवेयर भनेर बुझ्न सकिन्छ. जस्तै यसले चाहिँ बेसिकली राउटरहरूलाई चाहिँ कन्ट्रोल गर्छ. OpenWRT provides a user friendly web interface for configuration and administration, as well as a package management system that allows users to install additional softwares and features. The project is maintained by a community of developers and contributors, and it is released under the GNU General Public License. OpenWRT is also known for its stability, security, and flexibility, making it a popular choice for advanced users and developers who want to customize their networking devices. So next we have UCI, Unified Configuration Interface. UCI is a configuration system used in OpenWRT, LEDE, and other related projects. It provides a unified and easy to use interface for configuring different aspects of the system, such as network settings, system configuration, and package management. The configuration data is the configuration data is stored in hierarchical format using text files, making it easy to manage and modify the configuration using command line tools or text editors. UCI is designed to be lightweight and fast, making it suitable for use in resource constrained environments. Overall, UCI simplifies the process of managing and customizing OpenWRT and other related projects, making it a popular choice for embedded system and networking devices. Moving forward, we have OPKG. OPKG is a package management system designed for embedded Linux systems, especially OpenWRT and related distributions. It provides a command line interface for users to install, update, and remove software packages. OPKG can automatically handle dependencies and retrieve packages from online repositories. It is optimized for performance and efficiency, making it well suited for use in systems with limited resources. OPKG has a small footprint and supports both local and remote package management. Overall, OPKG is a simple and effective package management system for embedded Linux systems. So on the other hand, we have Lucy App SQM. Lucy App SQM is a web-based graphical user interface for the network queue management NQM system in OpenWRT and LEDE. It allows users to easily configure and optimize their network settings to improve network performance, reduce latency, and prioritize traffic. Lucy App SQM provides an intuitive and user-friendly interface for setting up NQM, including configuring upload and download speeds, including configuring upload, including configuring cost to configuring one of the configuring including configuring upload and download speeds, buffer bloat settings, and prioritizing certain types of traffics. It also includes real-time monitoring of network performance and statistics. Overall, Lucy App SQM is a powerful tool for improving network quality of service and is Overall, Lucy App SQM is a powerful tool for improving network quality of service and is widely used in OpenWRT and related distributions. So next to Abiral.
Hi, my name is Abiral Adhikari. I am a member of group KU Link 5.0 GHz. working on bandwidth management project. I'll be explaining about the setup procedures and give the demo of this project with my friend Samir Wagle. First of all, let me explain about the setup of this. In this project, we are using VirtualBox to set up Linux servers and virtual router to show the bandwidth management by the method of bandwidth allocation and rate limiting. Here we are setting up Oracle VirtualBox version 7.0, which was installed inside one of the laptops. After this, we installed OpenWRT version 21.02 by downloading its virtual disk image that supports 32-bit architecture inside of VirtualBox. We then installed two images of Ubuntu operating systems inside a VirtualBox that will be acting as the two devices that are connected in a single network. We then booted OpenWRT image and created LAN interfaces LAN and LAN1 and one interface WAN6. We connected both LANs with a virtual WLAN setup on virtual router via OpenWRT with IP 192.168.21.3 providing internet from virtual Ethernet adapter of host device. After this, we made OpenWRT router running. We then assigned static IPs 192.168.21.2 and 192.168.2.4 into the two Ubuntu PCs in the VirtualBox, naming them Ethernet 0 and Ethernet 1. Furthermore, we disabled DHCP for one setup and static LAN IP was assigned by OpenWRT router, which was same as the IP of Ethernet 0 and Ethernet 1. After which we installed Lucy SQM app in OpenWRT, which provides graphical user interface in the web for controlling the net traffic and network speeds, also along with network queue management services. We then visited the web page of OpenWRT. In the web page, we set the limits, download and upload both separately for LAN and LAN1. After setting up the speed limits in OpenWRT web page, we then went inside the Ubuntu, inside the VirtualBox, and run the network speed test in speedtest.com inside of to find the actual speed of the network, and the observation were noted.
Hello everyone, it's me Samir Wagle and I am demonstrating the project KU-Link 5.0 GHz. So let's start with project demonstration. First of all, we need a Oracle VM VirtualBox Manager which is responsible to create a different virtual devices and virtual router. So you can see in the screen we have two virtual devices named Linux and Ubuntu and one virtual router named OpenWRT Edge router. So first of all, let's configure the router, but that is virtual router. So in the tool section we can see the VirtualBox host only Ethernet adapter, and let's go to adapter and configure the IPv4 address and IPv4 network mask manually. So let's keep it as 192.168.21.2 as IPv4 address and 255.255.255.0 as IPv4 network mask, which is subnet mask. So in this way we have successfully configured the VirtualBox host only Ethernet adapter. Now the second work for us is to configure the router. So let's power on our router, that is OpenWRT is router. It's being turned on. So let's click enter. So OpenWRT has been successfully opened. Now let's enter the command UCI show network. This command lists out all the networks that are available in our router. So we can see LAN and LAN1 are two devices that in which the bandwidth is to be managed or controlled, and WAN is the device that connects these two devices, that is these two PCs with virtual PCs. And I have manually set the IP address of LAN, which is device first, as 192.168.21.2, and LAN 1, which is second device, as 192.168.21.4. The common netmarks for both devices, both Linux devices, are 255.255.255.0, and default gateway is 192.168.21.3. So this is the initial setup for our devices and for our WAN into the bandwidth management section. First of all, let's check out what is our actual internet speed is. For that, let's go to speed.test.net, go, and we can see it's quite high. It's around 75 Mbps. The download speed is 68.76 Mbps, and the upload speed is around 40 Mbps, that is 65.03. So these are the download and upload speed which is being provided by our internet service provider. And now let's configure the router. For that, we need to go to the default gateway, that is 192.168.21.3, and let's log in here. In the network section, there is SQM, QoS, Smart Queue Management. So we need to first set up the download speed and upload speed. Let's change it to 5000 as a download speed and 5000 as a upload speed. Let's save and apply it. Applying configuration, and the configuration changes has been applied. Now again, let's go to OpenWRT edge router and write command cat space /etc/config /sqm enter. In here you can see the option download as 5000 and option upload as 5000. It means our download speed and upload speed are kept at 5000. Now let's open Linux, and that is Ubuntu. Let's power on our device and let's check the internet connection in Ubuntu, whether that is being kept or not. So it should be around 5 Mbps, and the Ubuntu is opening. Let's log in. Yes. Let's open our browser and speedtest.net. Let's run the speed test. Let's check this internet speed from speedtest.net. Let's allow everything, and it's around 4.6 Mbps, and the upload speed is around 4.5 Mbps, that is the final result is shown in the screen, and the download speed is 4.61 Mbps and upload speed is 4.60 Mbps. So we have kept it as 5000 kbps, and we can see the result in our screen. Now let's try one more time, and now let's increase the download speed to 10,000 and increase the upload speed to 10,000. Let's save and apply it. This the configuration changes has been applied. Now again we need to open the router and we need to run the command cat space/etc/config/sqm, and you can see in the screen the option download 10,000, option upload 10,000. Now the upload speed and download speed is being increased to 10,000 kbps, that is around 10 mbps. So now let's again go to our Ubuntu and let's run the speed test. Let's allow everything that has been asked, and let's see the speed, whether our speed internet speed will increase from last result or not.
Let's see.
Let's allow it. Let's see.
Mbps. 8.88
Mbps.
The download speed is 8.88 mbps, which is less
8.88.
than
The download speed is
10,000
8.88
kbps,
mbps, which is
the upload speed
less
is
than
around
10,000 kbps, and
that is
the upload speed is around
9.44,
that
which
is
is less than 10,000 kbps. So
9.44, which
in
is
this
less
way
than
we
10,000
were
kbps.
successful to
So
manage the bandwidth
in
speed
this way we
our
were
project.
successful to manage the
In
bandwidth
this way,
speed
project
in our
demonstration is
project.
being done. Thank you.
So in this way the project demonstration is being done. Thank you.
After multiple tests and the observation showing near equal values of internet speed around set value, we can say that we have managed to successfully demonstrate the application of bandwidth management to using virtual routers and virtual devices in Linux. Thank you.